Hello good folks, and welcome to BWT's video about multimeters. And what we're going to cover today is measuring resistance and measuring continuity. So resistance is just that, it's the restriction in current flow. And then continuity is actually, means that it has a path for current to flow. And I've got some drawings up here we'll cover, and then we're going to go through and show how to utilize, these settings to test out different components and stuff, check out different switches. And so anyway, it's going to be a very interesting lesson on multimeters, on measuring ohms. I would say that I probably use my ohms and continuity testing and setting on the multimeter. It's probably my number one setting because two things are safety involved with it, because when you're testing, and you've got it set to ohms or set to continuity, then you have to have the power off. So it's safer. And just for an example, right here I've got a little drawing showing you, it's 3 e-stops, which you would run across, having multiple e-stop stations on a piece of equipment in an industrial environment. So it'd be like this. And this is showing them in the normally closed position. And I've got a purple line going right through here showing you that if they're closed, then you got a path for current to flow. So actually, if we sit there and we put this to ohms, or actually just go ahead and we put it to the continuity, because that's what we'd be testing this for, and we put our leads right here to here, it's going to read 0 or near 0. And it'll beep, just like this. Now, if we went down to this one, and somebody depressed one of these switches, one of these e-stops, and it was pushed, then if we measure from here to here, it's going to read 0, but if we measure from here to here, it's going to give you this reading right here. It's going to give you OL. Because we got an open and our current, the flow stops at this point right here. So that's a good way using, resistance and our measuring our ohms or using our continuity. That's telling us if we have flow or not. Now that brings up another point that I want to address. The difference between continuity is each meter has its own ranges and capacities and things of that nature. This one says that when it will beep when it's less than 25 ohms, and it stops beeping when it's greater than 250 ohms. So there's a range right there. So during troubleshooting, if we actually, so in other words, this says that it actually could beep if it was 200 ohms if we measure from here to here. 200 ohms is not really good. So, you'd have to be watching your meter also, not just listening to the tone. If you listen to the tone, you can hear that, and you're not paying attention to the meter, then it might have a resistance in there, which could be, like a loose connection or something else, and still tell you that you've got current flow through there, and you could still have an issue. But now, when you go to this setting right here, the ohms, then that's going to measure and tell you exactly what your resistance is in this whole circuit. So, if you might get the beep right here at 200 ohms, and then when you put it into the ohm setting, you won't hear the beep, but you can watch it, and it's going to tell you got 200 ohms, and you're going to know that you've got an issue there. So, when you're troubleshooting components or a circuit that finds, bad connections and everything, you will want to go ahead and then have it set to your ohms and then read your reading to see what it is. When you've got it set to the beeper, then you're just really checking to make sure that you got a path and that you haven't got an open. So basically, you got, see, there's a closed and there's an open. Same thing as if we had like a switch. This is a limit switch right here. And then the limit switch is made open. So the current path is from here to here, and it stops at this point. But now when that switch closes, then you're going to have current flow pass on through. Same thing with a fuse. A fuse is it's to go ahead and protect the circuit. So here's two different, drawings or, schematic symbols for fuses. And if it's good, you'll have a current flow through it. If it's opened up or burn open, then it's going to stop on one side and not the other. So you're going to get an OL. Same thing with this fuse right here. As long as, it's not opened up, it'll flow through. And if it's broken or burn open, it's going to stop at this point and not pass through the other side. Now, as far as on resistance, when you're measuring ohms, and we're going to test a few components over here, and I'm going to show you how to test them out, and then on your settings and what to look for and stuff like that. So bear with me, because this is going to be a really good tool and a skill for you to have when you're out there doing troubleshooting in an industrial environment or any kind of electrical components and stuff. So anyway, this is a symbol for a load, and then there's a symbol for ohms. This is a resistor, and there's a symbol for ohms. So that's what we're measuring, is we're measuring the resistance in a circuit, and it's measured in units of ohms. So right now, I'm going to go ahead and set a few things up for you, and then we'll cover that. And then I'm going to demonstrate how we can use this to do some troubleshooting. Here's some components that you'll run across. We got relays right here, we got motor contactors, and we got fuses. So we can go right here, and let's just take this one. And then I'm going to move it up here a little closer so that you can actually see what's going on. Okay, we can see that now. All right, so let's give this a try right here, folks. With it set to ohms, we can sit there and we can measure our coils, which a coil is basically just a set of windings and everything. And as you can see, this one measures 68.8 ohms. Okay, if you had another one and this wasn't working, you can compare that 68.8 ohms to another one, and see if they're measuring the same. Now, if it was bad, it could be shorted out, and it would be, like 0. Or if it was burn open, then you would get an OL. Now this one, all coils are not the same. So if we look at this one, this one's 99 ohms. So it wouldn't do justice to compare from this to this. And we can also check continuity. Like this says it's normally open. And see, we got an OL. So OL means it's open. And then anything 0 to that, to infinity, is telling you what your resistance is. Now this is another set of relays right here. And I got two of them like, that are alike. And then so if we check this one, okay, see how that's fluctuating right there? Now that's telling one of two things. It's telling that we either got a bad connection or we got a bad coil. So the first thing that you would want to do is make for sure that your terminals are good and tight, so that you're not, that could actually be the issue right off the bat. So let's see if by tightening up the terminals, if by measuring our continuity or our resistance, helped us find a problem. And yes, it did. That one's 443 ohms across that coil. Now, we'll go ahead and we'll tighten this one up. So that's something to always keep in mind when you're checking things. Make sure you know that you've got a good connection with your probes. And see, that's 442.8. So these are measuring real close to the same, so that'd be a comparison. So if this one wasn't working and you measured, say, like the 90 ohms like you did over here on this one, and this one measured 442 and this one's working and this one's not, you would know that that's bad. Now, as far as on measuring on our continuity, which is our tone, you can use that for your fuses. So see that, and so that's a good fuse. Uh-oh, what have we got going on here? See, we got OL. We got OL on that one. So we either got two bad fuses, and this one's good, or, look here, we don't even have fuse in there. But it's going to be the same thing as if that fuse was blown. So now that's measuring some components and showing you how to use a meter on resistance, continuity. And I'm going to show you a resistor right here. See, now that's showing you that we've got 10 ohms. And that's what this resistor is. It's a 10 ohm resistor. I've got another resistor right here. Okay. Now, see, we got it set to the beeper. And did you notice at 10 it went ahead and beeped? But we did have a resistance. And then that's what I wanted to go ahead and address, is that you got to be careful, because that was telling us that everything's good, but we still had 10 ohms that would have been in that circuit right there. So if we go ahead and switch this over, now see, this is 330 ohms and it wouldn't beep. And just to give an example of that, I've got a pot, which is a potentiometer, so that just means it's a variable resistor. And we're going to go ahead and we're going to put our okay, see, we got a beep right there, 10 ohms. Now this actually said that this meter was, it stops beeping at 250, but this one is actually a tighter tolerance than that. But see, it will still beep at 20, and it'll beep at 60. And it stops somewhere between 60 and 70. 60 and 70 is enough to present a problem. So, you know, you have to really be watching your meter when you're doing this. And if you're having, you know, issues even after you've checked it out for continuity. So just keep that in mind when you are doing the beeper, that you can have a certain resistance, which if you remember, that resistance was greater than the resistance of this coil. And that coil is a load. But, you know, this is a tremendous tool, and a skill to have is to know how to use your multimeter for resistance measuring and for your continuity. And as far as switches goes, it's just either on or off. So, you know, you just need to know that open is OL, resistance is any value between 0 and OL, and continuity, or a closed circuit, which is what you're wanting flow, is going to be very near 0. So that's got us on that. And I would like to bring up a point right here. If anybody's interested in getting into the field, the industry of maintenance, I've got a essential checklist right here that I'm giving away, and there's going to be a link underneath of this. It's betterwaytraining.com/sign-up-3096. I'll go ahead and have that link below this video right here. But if you know anybody that's wanting to get into the field as a maintenance technician, this gives you a step-by-step guide. It's a checklist to make for sure that you're prepared when you go in for an interview and everything. And this is free. It's just to help you out. It's like I said on this channel. This is for the success for a maintenance technician. And this will be something that will help you out if you're interested in getting into the field of maintenance. Gives you everything. Starts out with a mindset. Tells you about researching and assessing your capabilities. Knowing what it is that you want to do ahead of time and not wasting time. So this will give you a direct, quick path, fast track to success as a maintenance technician. And I will see you on the next video. Subscribe this so that you know when it's coming up. And it's actually going to be covering the multimeter's extra functions like hold, your bar graft, min, max, and all these other different things, you know, temperature, measuring hertz, and things of that nature. So it dives in a little bit deeper. So I will see you on the next one, and you have a great day. Thank you.